Okay, so in today's class we are going to discuss about software design strategies. Okay, in our previous class what we have done about our cohesion and coupling. At that time we also have seen that how we were designing our software. At that particular class we have seen that structured design. What was structured design? We have talked about that one also. Here we will see different strategies of our software designing, right? Okay, now first one is our structured design. How we are going to do the designing in case of structured phase. Okay, so first one, what we see, conceptualization of problem into several well organized elements of solution. As first of all, what we know about software designing, that is conceptualization of the whole system, that is our requirement. We are just changing or transforming the requirements what we have into our implementation. Whatever requirement we have gathered, that we are transforming into our implementation. Okay, that is what we are doing in the designing phase. Here what we just try to get an optimal solution. As we have already discussed that the designing, what we have to do here, it is the first phase where we are working on solution domain. In the feasibility study and requirement analysis and specification, we were working on the problem domain. Now we are working on the solution domain. Obviously, now let's come to this point. Here, conceptualization of problem into several well organized elements of solution. Obviously, we are talking about solution. Now, what we used to do in our structured designing, as we have seen in our previous class, we were breaking the design. We were breaking the whole system into what? Some small subsystems, and again those subsystems into some small modules. So what they were well organized elements of solution. How we were using those elements, that is modules or elements in that modules also, what we were doing in our cohesion and coupling. So these kinds of things, these are well organized elements which we were using in the making of this structured design. Okay, now they were well organized. As we have seen in cohesion and coupling also, the elements should be well organized so that your high cohesion and low coupling thing will be satisfied. Okay, now second one, that is better understanding of the problem. As we have seen there also, that whatever problem, here we are working on what? The solution domain. Then, so when we are working on the solution domain, we have to have a better understanding of the problem. You have the requirements, you have the problem now in your hand. Now you have to have the better understanding of the problem so that you can get the better solution for your designing phase, so that you can get the better software, better and best quality software. So better understanding of the problem should be obviously there. Now third one, divide and conquer strategy. What we have seen there in structured designing also, in designing phase, what we were doing, we were breaking the problem. Here the whole system, what we were doing, we were breaking the whole system into small subsystems. Those subsystems into small modules. So we were just dividing a particular problem into different subsystems, different modules. We were conquering that. We were solving the problem of those subsystems and then again merging those things into a whole system. That will be your solution system or your solution software. So dividing and conquering those things, from that big system to the small subsystems, and then conquering those problems, so that what happens there, if you are breaking your system into subsystems and then modules and then working on that, what will it help? It will help you in, if some error comes, if some fault comes, then it will only affect those particular modules or those particular subsystems, not your whole system, so that you can easily cope up with that particular error or any fault. So in this case, when you are dividing and conquering, this strategy, why we are taking this strategy, so that the whole system is not affected at once by any kind of fault or any kind of calamities. So here what we do, we just use this divide and conquer. Next, well organized modules. We have seen also in our cohesion coupling that we were working on modules, how the modules were working, and how, as in case of coupling, and how the elements in a particular module how the interdependability between them. We were seeing how the modules working on the same, the elements working on same time. They were doing the same task at an instant of time. So these kind of modules, what we have to see there, that is well organized modules. Your modules should be always well organized so that they can easily, we can group them into different cohesion and coupling groups. Also, you can easily give a structured pattern to your designing phase, right? So now next, good design, that is having a high cohesion and low coupling. We have seen in coupling that no coupling is ideally perfect, but in case of cohesion, the ideal cohesion was our functional cohesion, which was the topmost cohesion in case of, that is high cohesion in case of cohesion branches. Okay, so high cohesion and low coupling is always seen for a good and better quality designing. So these are the things mainly what are the characteristics of our structured designing concept. Okay, so these points should be obviously seen in case of when you are working in the structured kind of designing strategy, right? Now we have to see the next one, that is our function oriented designing strategy. This is the second one. So let's see one by one what are the points, so that we can easily know about function oriented designing. What happens here? Same thing. Again here we break the whole system into subsystems. Okay, comprises a smaller subsystem known as function. Same thing. It is your system, that is S1. Then you are breaking that into smaller subsystems. Suppose this one is here what happens now, these subsystems, there we were working on subsystems and modules mainly, right? Here what happens, these subsystems, suppose 1, 2, 3, so these are mainly functions, that is F1, F2, F3. These smaller subsystems, when you're breaking the system into, these smaller subsystems are mainly known as functions, because they are doing some different kinds of tasks. There we were seeing breaking the subsystems into modules, but here your subsystems are known as smaller units that are known as function. Why? They are doing some specific work, some specific function. That's why we are calling them, these subsystems, as smaller function. Now what happens? Divides the whole system into small size functions. The whole software, your whole designing, that is your whole software is going to do some function. Okay, now when you're breaking that whole software, we are breaking those into smaller functions. Again same thing, same concept, divide and conquer. Why? Again you have to see that every small, so that what happens, whenever you are working, you are concentrating on a particular function, you are getting a small function, a small subsystem. You are working on that so that other functions or other subsystems, they are not affected at once. Same thing is happening here also, but we are calling them function as they are doing some specific kind of work. Third, functions share info by info passing, that is how they are sharing their info. Okay, or using global data information. How they are sharing their information. So information can be shared, that is your data sharing. How they can do? First one is, that is passing parameter. Okay, passing parameters. Passing parameters means, in this case what we will see, that is the information. They are passing the information from this function to this, or from this to this. They are just passing the information from one function to another. So this is the thing, how they are interconnected. These functions are interconnected with each other. So they can, how they can share their data, they can obviously pass the parameters. In form of parameters, they are passing the data from one function to another. Or second thing, what they can do, they can share the data or use the data of the global data. We are having a global data. Suppose this is my D1 set, that is my global data. Okay, this is my global data, and these functions F1, F2, F3, anything F up to Fn, they can get the data, use the data of this global data. They all can easily share the data or get any information from this global data. So two things they can do. First thing, what they can share the data into, they can interchange the data, or they can share the data between them. Or second, what they can do, they can get the data using this global data. Global data is there, which is having all kinds of data, and every function have the eligibility, or they can easily access that one. They have the authorization to access that global data, so they can easily get the information from this global data. Then now next one, data flow is shown by DFD. Now in case of this functional strategy, what we see in function oriented strategy, the main thing that we use is the DFD. How the data is flowing. We have shown you how the data is flowing from one function F1 to F2 to F3, how this is going on. Okay, so this thing is going on from this to this. This is what? This is data flow. And how we will show this data flow? By DFD, that is data flow diagram. Okay, so data flow diagram, what this do? This basically shows us the how the data is flowing from one entity to another entity. Okay, from one function to another function, how this data is going on, how this data is flowing. So this DFD we will see in another classes in descriptive manner, that how this DFD are working. The level 1 DFD is there, level 2 DFD is there, the basic DFD chart is made. So how this DFD data flow diagram is done, that will be seen another class. But here basically you can know that data is flowing, and we will show that data flow in the pictorial form, that is a DFD. Okay, now DFD shows what? How function changes data and state of system. Mainly, one more thing. Here, program, basically here what happens, the program mainly works on, here in case of function oriented design, here what happens? We have seen that one function is there, F1, one input is given here, IP, and one output is coming from this. And we have seen this basically, what is this function? Here what happens, this is my input and output. Here some processing is done. Okay, the data is processed here. Whatever data I am giving here as input, that is processed here. So what is this? This is mainly the state of my program. Now what is the state of my program? Maybe it can be active, inactive, or anything. So it can be idle. So these things, the state of my program, this is changing when a function calls. Okay, mainly the state of the function, that is state of the program, it basically changes. But the input which you are providing to this thing, this input never changes. Since you are giving an input, you are getting an output. The input not changes, but the state of my program is changing. Mainly sometimes it's active, maybe sometimes it's idle or inactive. So these partially active. So these things are changing the state of my program. So this basically this affects your program at a instant of time. So here in function oriented design, what happens? Our function oriented design mainly focuses on the input, and it doesn't focuses on the state of your program. Whatever is your state of the program, it doesn't affects your program, or it doesn't affect your function. It basically what happens, it mainly focuses on the input. Then, so it's a very much is a privilege, since it's not seeing the state of your program. So obviously it is a privilege for the development team. So here what happens, it is focusing on the input and not on the state of the program. This is also one point. So changes of the state of the program, if your state of the program is changing from active, idle, anything, it will not hamper your function, your designing, okay, or your working of your software. So this what happens in your function oriented. Now we were talking about DFD, okay, data flow diagram. Now what happens, what this DFD shows you? Data flow, okay. Second thing, how the function changes. Function changes. How your function is changing from this function to this function. So this function changes which function you are working upon on a particular instant of time. This thing is shown by your DFD. How your function is changing, how your working is changing. Okay, from this, mainly the flow, how the flow is going on, data flow. So this from this function to this function, this one, that is the main thing. So this thing is shown in your by your DFD. And second thing, what it shows is the state of your system. What is the state of your system? These things are shown by your DFD, data flow diagram. We will see in next class. Now last one is system broken into smaller units, that is function. We know that the system is breaking now the system has been broken into some small subsystems. But what is happening here? How we are breaking that one? As I have already told you that since what is a function? Mainly function is what? A working, mainly a work done by something. So here what happens? On the basis of operation, what kind of operation your function is doing. So in that particular manner, on what kind of operation your function is doing, we are going to break or group those functions, or when we are breaking the system, we are going to group that on the basis of the operation, what kind of task your function is going to do. This grouping is done on the basis of that particular operation. Okay, suppose this thing, how they are working, maybe this is working on some function, this is working. So grouping is done, basically grouping is done on, or breaking is done on this thing, that is the work of the operation, on the basis of operation of the function or working of the function. Okay, you can easily break that smaller units. We are grouping those units on the basis of this particular operation. Then now what is happening? Each and each function, that is all the functions as described in, then what happens when we are grouping, we are breaking those functions, they are working, and what happens? Then we are seeing that again we are merging that one. Divide and conquer, we have seen what we are dividing the function, dividing the whole system into smaller units, and then we are again what, after the working is done, the conquering is done, your problem is solved, then you are merging the whole thing. Here also same thing, we are breaking the function into some small, we are breaking the whole system into some smaller functions. That is, here it is my F1. Okay, then smaller functions we are breaking it into, and then again merging those whole piece of things into that F1 again when your work is done. Okay, so this thing is what is done in case of function oriented design. We are breaking the system into smaller subsystems, that is that smaller parts are known as function. Basically the main thing, how we are breaking this, doing this grouping, that is on the basis of their operation, what kind of functioning they are doing, what kind of working they are doing. So we are breaking on that basis of that operation. And main thing is that it is working on the input of my data, it is not working on the state of the operation. It doesn't matter whatever your state of the program is, it doesn't matter on that one. Then, and we have to see that after the whole thing is done, then each function is described in large. Every function we are describing in large. After every function, suppose 1, 2, 3, 4, so every function, now we have done what on all the functions. Now every function, suppose this one was F1, so they are described in large, and after everything we are merging those functions. This is what is happening in our function oriented design. Now we will see our third most, that is our object oriented designing strategy. These are what was the first one was structured, second one was our function oriented. Now we have to see the object oriented design. It's a typical one. Now what happens in the object oriented designing? We have seen Java, that is our object oriented language. You basically have some idea on what is object oriented thing. Now here mainly in object oriented thing, there basically something works on entities and their characteristics. Here what happens? Suppose what are entities? Entities are mainly what? Suppose this is my entity. Suppose we are talking about bank, a particular entity, or we are talking about student, a particular entity. That means what? A certain object. We are working on a certain object. That is our entity. So characteristic of those entities, that is our attributes. They are called attributes. Okay, these are entities and some attributes are there. Entity and attributes. Okay, attributes. So these kind of things are being worked here on object oriented designing. Then so here what we have to see, we have to know about some specific terms which already we know in our object oriented programming, that is in case of Java. So here we see that this is my bank or student, whatever this thing is called by entity, that it has some attributes. Suppose if this is student, then they will have some roll number, some name, etc, etc. So these kind of things are my attributes, that is characteristics of that particular entity. Okay, now let's see what are the things, what are the basic terms which we use in case of object oriented designing. Okay, there are some basic terms which we have to see in a brief manner. Okay, first one is our objects. First one is object. So what is the object? Mainly a object is an entity, which I have already told you, an entity involved. Entity involved. How we are going to work upon a particular entity, that is an object. Object is mainly an instance of a class. Okay, we will see what a class now. Now object means, suppose example we can give bank, student, okay, teacher, etc. So these are basically entities, means object. We are working upon these objects. Then so this is what is my entities are. Now these entities, what they will have, they will obviously have some attributes, that is their attributes or their characteristics. Okay, particular characteristics or maybe some qualities. Okay, that is if particular student is there, they will have some character, that is they will have some name, some roll number, some registration number, their address, their phone number, etc., date of birth, etc., etc. So those things will be their attributes, that is student name, roll number, okay, different attributes, maybe class and address, etc. So these are what? These are our attributes. Okay, this we will work upon in case of object oriented design. Then second one is what? Second one is our class. What happens in a class? Class is the object, is the instance of class. Okay, in case of class, what we see, general description of that object. Okay, that is, as I have already shown you in attributes, general description. These are my general description of this particular object. General description of this particular object, that is we are saying that class is the instance of this object, or object is the instance of the class. Okay, so here we have seen two things. One is we are working upon object, and second we are working upon the classes. Then third one which we will be working upon, that is encapsulation. Encapsulation what? When we are working upon the attributes, okay, and methods together. When we are working upon attributes and methods together, they are then that process is known as encapsulation. We have read this all topics in Java also. And what happens here? It mainly restricts the data. Data hiding, we have already studied about data hiding. What it do, that is it restricts the data, outside data, restricts the data from outside world, data from outside world. That is our encapsulation. Then this is also a term related to Java. We have seen there also. And next one is inheritance. Inheritance. What is inheritance? Basically, if you are having any particular object or any particular class, so this class can inherit some information, or it can inherit some characteristics, some particular whatever, maybe some data that it can easily inherit from its upper classes. This is the class and these are upper classes. Suppose this is A, so this is B, C. They can inherit the data. Maybe this can inherit the data from A, B or C. This means it can take the data, it can reuse that data, as well as it can take the data and use it as a global data also. So this kind of inheritance is this kind of taking of data, that is called inheritance. Different inheritance, multi-level inheritance, single inheritance, different inheritance are there in our topic also. So basically inheritance means taking the data from our upper classes. Okay, taking data from using the data of upper classes. This is called inheritance. This also we have seen. Now polymorphism. What is polymorphism? Polymorphism, that is we are using some classes, we are mainly some methods, we are performing some we are using some methods. What methods? These methods will be having same name, but they will do some maybe the function is also they can do the same function also. So basically they have the same name and the function is also same, but vary in arguments. When we are talking about arguments, you have seen there that we are having some arguments, suppose a and b. Here we are talking about a particular function, suppose int. Okay, so ab, but here also int, there will be a, b, c. So these are what we call arguments. So this will differ in this, that is the arguments will be different. The method, in case of these methods, same name. Okay, function may be also same or different, but the arguments will be different. So this is what happens in our polymorphism. So these are the things which we work in case of object oriented designing. As these things are, you have already seen in Java also. So these things are used in case of when we are working upon object oriented designing. Basically what happens in object oriented designing, whatever previous data is there, we only work upon that data. Suppose some data is there already, previous data is with us, or some requirements are with us, we basically take that requirement or reuse that data. We are basically doing these things in case of object oriented designing. Some previous work had been done, and from that work we are taking something and we are reusing that one. This is what happens here. That is, this is solution comes from requirement or previous system. Any previous system which you have, from that previous system only you are getting those particular data. Now what happens? Objects are grouped into classes on behalf of similarity in characteristics or attributes. What we are doing, we are mainly grouping these things, grouping the classes on behalf of similarity of attributes, attributes of characteristics. These characteristics of these attributes, these similarities are being taken for the grouping purpose here. In case of function also, we have seen how we were grouping the functions together on the basis of operation. Here on the basis of characteristics of the attributes. So here we are mainly on the similarity of the attributes we are working here. Okay, and class hierarchy is there. As we are using inheritance, we will obviously see a class hierarchy. Like here, from we are taking inheritance, that is from this class, so we are inheriting from these classes, as we have seen already. So this kind of class hierarchy is followed in case of object oriented designing. Then next is relationship. We obviously, when we are talking about entities and different kinds of attributes, okay, so what we see mainly here, we use UML we use. Okay, and in case of entities, relationships, these things which we are mainly talking about entity relationship diagram. Suppose when you are talking about a student, okay, now here suppose you have another entity, teacher. So what happens? These will have some particular relationship between each other. What relationship? What happens? Teacher, what they do? They basically teaches. So here teaching is what is the relationship between student and teacher. Now book, if it's another entity, so what is the relationship? Reading. Read is the relationship between a book and a student. So this is what is called relationship. So these kind of relationship are being worked upon in this object oriented designing. Then so what happens in this particular in all the strategies, what the common concept is, that is we are breaking the whole system into smaller system, and we are working on those smaller systems so that at a particular instant the whole system is not affected, but the strategy is different. That is, in case of structured design, we are breaking in subsystem, modules, etc, etc. In case of function oriented design, we are breaking into subsystems which we are calling function, as it is mainly basically grouped on basis of some operations, that is some functions. And in object oriented designing, what we are working on? We are working on objects, on classes, on attributes, on relationships, etc, etc. So these are what are the things which we use. Basically this one is used when you are working on some previously done system, when some previous system is there with you, or some requirements that had been used, those requirements are there, you can reuse the system in case of object oriented system. Then now what we will see, there basically two kinds of designing processes what we follow. Okay, that is also our strategy. But these two kinds of things are mainly followed when you are talking about a designing phase. One is top down and second one is bottom up. These are the two designing strategies, top down designing and bottom up designing. Okay, what happens in top down, that is, suppose here from a system, in top down what we basically do, we have subsystems and we are working upon them. Okay, what we are doing, this is my subsystem and we have to work, that is we have to break it into subsystems, different subsystems. That is, this is our higher level function, and what we are doing, we are breaking that into lower level until and unless we are having the basic structure, basic level, that is our basic one. Okay, basic level we are getting, we are going on breaking this thing several times, same thing, breaking, again subsystem breaking. So from top level program we are going to the basic level, then we are going from top level to basic level. And here what happens, obviously this one is your whole system, then you are going upon breaking and you are getting the basic system, the basic component of your whole software. This is called the top down approach. Okay, in top down approach mainly what happens, the whole system is taken into a entity. This we are working as an entity. Now we are decomposing this entity into different subsystems level by level until and unless the basic thing you are getting, the basic subsystem you are getting, you are going on breaking that one. Then in bottom up approach what happens, different thing, that is, now we are going to work upon the lowest level. From bottom up lowest level we are going to decompose. Now we are just making them, joining them, and we are working until and unless we are getting the whole system, that is our higher level system, main system, the whole software. Until and unless you are getting the whole software as a one entity, here from one entity you are going on breaking that until and unless you are getting the basic component of your software. Here what happens, from this basics of, this is your basic level, this is your basic component. From these basic components, obviously many components are there, from these basic components you are going on attaching, you are going on doing the abstraction is going on high, okay, increasing level. So this thing you are going on just merging, going on merging from this to this until and unless you are getting the single entity, that is your whole system, this single entity. This is your higher level function, this is your higher level, the highest level. Same thing we are going on doing, that is we are merging. There we are decomposing, we are just breaking the system, and here what we are just going on merging the system. So this thing is going on in case of top down and bottom up approach. I think it's clear for you. Now in next class we will go with some another topic, and if you have any kind of doubt in case of this designing strategies, you can write to comment section. I will reply to your comments, and obviously if you like my channel then please like and subscribe so that I can give you more information or more informative video on this technical lessons. So thank you.